Hello my beautiful students. So your exam is very close and at this moment I know you are preparing well, but also some of you are very much worried about the numerical problems. So yes, here I am with the top 50 numericals. So I guess after watching this video all the doubts related to your numerical will be cleared. So yes, without further delay, let's get started. So the agenda of today's class is going to be like we will do 15 numerical from the solution, 20 numerical from the electrochemistry and 15 numerical from the kinetics, total 50. Okay, so yeah, see, for this particular lecture video you can expect complete marks in your section E, that is a numerical zone. So to get this, very basic steps that you have to follow. Step 1, that correct formula you have to write. Okay, correct formula. Step 2, this is your step 1. Step 2, correct substitution. Okay, and final step, that is proper calculation plus unit. Okay, so this will give you 1 mark, this will give you another 1 mark, and this will give you another 1 mark. So one additional step, let it be step 0, okay, that you should go through in order to make this thing work properly, that is write the given information. Okay, so these 3 steps, if you have been through properly, then you will get proper 3 marks. So how you should do? So let's start with the chapter solution. Okay, so first question, let's move. Calculate the molality and mole fraction of the solute containing 3 gram of urea per 250 gram of water. So let's write what are the given things. So here you can see, you can write that is a molecular weight of the solute. Solute is urea, right? It is given as 3 gram. Okay, then molecular weight of urea, that is M2, you can take M2 of urea. Okay, so M2 of urea is basically 60 gram per mole, right? Next, mass of water. So W1 means weight of the solvent. Okay, that is basically 250 gram. Okay, now molecular weight of water, M1 of water, okay, that's going to be 18 gram. Fine. So now molality formula you write. Okay, that is the number of moles of solute divided by weight of solvent, right? Weight of solvent in gram into 1000. That is a formula. Further, number of moles of solute we can break it down to given mass by molecular weight, right? Into weight of solvent is W1, right? Here into 1000. Okay, I guess this is clear to you. Now what we are going to do? We are going to substitute. So up to this you can ensure 1 mark. Then you can substitute the value. So if I substitute the value, so here I am going to get 3 gram, right? 3 gram. Here I will get 60 gram, right? 60 gram per mole. 60 gram per mole. How much water? 250 gram. 250 gram, and here I will get 1000. Okay, so if you just calculate this thing, you will get your answer, that you can see. 0.2 is your molality. So you will end up with the answer 0.2 small m, that is the molality. Okay, so now what you have to do? We have to find out the mole fraction as well. Okay, so molarity and mole fraction of the solute. So mole fraction of urea. So mole fraction of urea is going to be number of moles of urea divided by total number of moles. Number of moles of urea plus number of moles of water. Okay, so I am just directly doing it. You can do the calculation later. So 3 gram divided by 60, right, divided by 3 by 60 plus 250 by 18. Okay, so if you just do the calculation, you will get the mole fraction, that will come up to be 0.0039. Okay, I'm not going to the detailed calculation, I'm just showing how you should go ahead, and you can see the answer 0.0039. I guess this is clear to you. Let's go ahead with the next problem. 22 gram of benzene is dissolved in 122 gram of carbon tetrachloride. Determine the mass percentage of carbon tetrachloride and benzene. Okay, let's do it. So first, mass of benzene, right? Wait. Weight of benzene is given as 22 gram, right? Okay, weight of carbon tetrachloride CCl4, that is also given, that is basically 122 gram. Okay, so percentage mass, if you want to find out, that is going to be mass of benzene, right? So weight of benzene divided by total volume, total mass of the solution, total solution into 100 here. Okay, so mass of benzene is how much? 22 gram. Okay, now here total solution, how much you will get? 22 plus 122 gram, right, into 100, right? So that will give you the answer. If you calculate, your answer will come up to be mass percentage of benzene is coming as how much? 15.28. It will come up to be 15.28%. Okay, so now if you just find out the percentage of CCl4, percentage weight of CCl4, then 100 minus this, 100 minus 15.28 you can do, and you can get the answer. Okay, that will come up to be something 84, yes, 84.72%. Okay, that is the answer. I guess this is clear to you. Let's go ahead. The mole fraction of helium in a saturated solution is given. Okay, find the pressure of helium above the solution. Henry's constant is also given at 20 degrees Celsius. Fine. So what we can do? Mole fraction of helium is given something 1.2 into 10 power minus 6. Okay, KH value is given, that is the Henry's constant. How much? 144.97 kilobar. Fine. So now you can simply apply the Henry's law, that is pressure of helium is going to be KH into mole fraction of He. So that's going to be 144.997 into 1.2 into 10 power minus 6. So whatever the answer, it should come in kilobar. Okay, so make sure that you are writing the proper formula, 1 mark, proper substitution, 1 mark, correct answer with the answer, another 1 mark. Okay, so I guess this is clear. Your answer should be something, okay, this should not be in Pascal, this should come in bar. Okay, so it should come 173.96. Okay, I guess this is clear to you. Let's go ahead. The vapor pressure of a pure liquid A is 40 mm of Ag at 310 Kelvin. The vapor pressure of this liquid in solution with liquid B is 32 mm of Ag. Calculate the mole fraction of A in the solution if the mixture obeys Raoult's law. Fine. So this type of problem, it's a kind of HOTS or TICKI, you can tell, a little bit tricky, but not that much. Just if you follow the simple formula of Raoult's law, it will give you the answer. Okay, so let me just tell you. Vapor pressure of A, let's say PA naught, okay, that is given how much? 40 mm of Hg, right? 40 mm of Hg. Okay, now vapor pressure of A in solution, that is also given, that is PA. What is PA? Vapor pressure of A in solution. Okay, that is also given. You can see the vapor pressure of this liquid in solution with B is 32 mm of Hg. That is given as 32 mm of Hg. Fine. Now, if you just follow the Raoult's law, PA is basically PA naught of XA. This is in accordance to Raoult's law. Okay, so now if you just have to put the things here, so mole fraction of A is coming something like 32 by, okay, let me just write it again. It is coming as PA by PA naught, right? So mole fraction of A will come up to be, PA is 32 divided by 40. Okay, I guess this is clear. How much? It should come up to be 0.8. Okay, I guess this is clear to you. Okay, let's go ahead. Calculate the mass of a non-volatile solute. Molar mass is given 40 gram per mole, which should be dissolved in 114 gram of octane to reduce its vapor pressure to 80%. So here, this is also type of HOTS question. Okay, or tricky, you can say. Let's go ahead. So at first, what you have to do, you have to just note it down. What are the given thing? So molar mass of the solution, M2, it is given as 40 gram. 40 gram per mole. Okay, next, weight of octane. So weight of octane means octane is the solvent here, right? Is dissolved in 114 gram of octane. So octane is the solvent. So weight of octane here is basically 104 gram. Okay, this is for the octane. Okay, next, molar mass of octane. If you find out molar mass of octane, octane formula is C8H18, right? So if I just find it out, 12 into 8 plus 18, how much it will come? 96 plus 18, right? 96 plus 18, it should come up to be 114 gram per mole, right? Now vapor pressure of the pure solvent, that's going to be 100%. Now whenever it is dissolved, vapor pressure reduced to 80%, right? So I can write P naught. P naught is basically 100%. Okay, and reduced pressure, P is basically the reduced pressure. Okay, how much? 80%. Okay, so now what we are going to do, so as you can see, there is a lowering of vapor pressure. We can use the formula of RLVP. So P naught minus P divided by P naught is going to be X of mole fraction of 2. Okay, so that's going to be further, let's say N2 by N1 plus N2. So if I just further simplify it, so N1 plus N2, any one you can take, octane you take as a major one. So N2 by N1, I am simplifying it. N1 I am simplifying it. So now if I just do it, W2 by M2 into W1 into M1. Okay, so now here if I just put the things together, P naught is coming up to be the here 100%, right? 100 minus 80 divided by 100. Okay, equals to W2 we have to find out. Okay, into M1 is how much? 114 divided by M2 is 40 into W1 is how much? W1 is also 114. Okay, so if you just calculate this, you will get the W2 value. Okay, so let me just simplify this thing a little bit for you people. So from here I am getting 20 by 100. Okay, so here I am getting 40 into 104 into 114. Okay, so this will be cancelled out. Okay, W2 is coming up to be 8 gram. Okay, I guess it is clear to you. Yes, it's 8 gram. Okay, so I guess there is no problem. Let's go ahead. The vapor pressure of 5% aqueous solution of a non-volatile organic substance at 373 Kelvin is 745 mm. Calculate the molar mass of the solute. Okay. So first, again, let's write what are the given thing. Weight of the solute means W2. W2 is given as 5 gram. Okay, weight of the solvent W1, it is given as how much? Okay, 5% aqueous solution they are saying. If it is 5 gram, then definitely weight of the solvent should be 95 gram. Okay, next next what we can do, that is the, okay, next what we can do, that is molar mass of the solvent means water. So that's going to be 18 gram for water. Okay, so that's going to be solute. Okay, that's going to be solute. This is my solvent. Okay, this is molecular weight of H2O. Okay, I guess this is clear. Now for pure solvent. Okay, for pure solvent, vapor pressure for solution. Vapor pressure for the solution is given, that is P is given, P of solution is given, that is 745 mm of Hg. Okay, and P naught is basically 760 mm, right, for the pure solution. For water, okay, this is for water. Fine. So now what we are going to do, we are going to put all this information into the relative lowering of vapor pressure formula. So let's do it. So again, P naught minus P divided by P naught is going to give you again N2 by N1, right? So again, if I just simplify this, W2 by M2 into M1 by W1. Okay, let's put everything here. So 760 minus 745 divided by 760 is going to give you, okay, 5 gram molecular weight you have to find out, into M1 is molecular weight of solvent is 18 gram divided by 95 gram of water. Okay, so from here if you just calculate this further, it's going to give you something, from here how much you will get, 15 divided by 760 equals to, from this side, okay, from here if I just cross it, this will give you 19. So 18 by 19 M2, right? So from here M2 you are getting something like 18 into 760 divided by 15. Okay, so if you just do this calculation, you will get the molecular weight of the solute. So it's going to be 48 gram. You will get it 48 gram per mole. That's it. Okay, so I guess this is clear to you. Let's go ahead. The vapor pressure of water is 92 mm Okay, let's go ahead. The vapor pressure of water is 92 mm at 323 Kelvin. 18.1 gram of urea are dissolved in 100 gram of water. The vapor pressure is reduced by 5 mm. Calculate the molar mass of urea. Okay, let's do it. So here what you have to do, the things that are given first, write P naught, that is for water definitely. It is basically given as how much? 92 mm. 92 mm of Hg. Right. Now weight of urea, W2 is also given, that is 18.1 gram. Okay. Water is also given, W1. Okay, 100 gram. 100 gram of water. Okay. Now molecular weight, M1 also we know, that is 18 gram per mole. Okay, let's go ahead with the delta P we can find out here. Delta P by P naught, okay, equals to N2 by N1. Okay, so delta P is how much? It is already given, 5 mm. 5 mm of Hg divided by P naught. P naught is basically 92. And here if I just substitute this with W2 by M2 into M1 by W1. Okay, so if I just substitute the thing, so 18.1 divided by molecular weight we don't know into M1 means molecular weight of solvent, 18 divided by 100 gram. Okay, so from here if you just calculate M2, you will get your answer. Okay, so M2 definitely it will come up to be something like gram per mole. Okay, so here you can see the answer is basically 59.99. 59.9. Okay, so anyway it's urea, it's given, we all know that it's nearby 60. Okay, I guess you understood this. Let's go ahead. Okay, let's go ahead with the next problem. Calculate the boiling point of a solution containing 25 gram of urea and 25 gram of thiourea in 500 gram chloroform. The boiling point of the pure chloroform is basically 61.2 degrees Celsius given. Kb is also given. Fine. So first we will just write down the information. So weight of urea, if you write, weight of urea is how much? 25 gram. Right. Now molecular weight of urea, if you write, that will be needed actually 60 gram per mole. Right. Now weight of thiourea, how much they have given? That is also 25 gram. Right. Now molecular weight of thiourea, if you just calculate, it will come up to be 70. Okay, 76 actually, 76 gram per mole. Okay, so now what you have to do, one more thing is given, that is TB naught, right? TB naught is given as 61.2 degrees Celsius. Fine. Another one, Kb is also given. Kb is something 3.63. Okay. Now what you have to do? Find out the number of moles out of it. Okay, so what you have to do, number of moles of urea, if I calculate number of moles of urea, it's going to be 25 divided by 60. Okay, number of moles of thiourea, if you find out, so that's going to be again 25 divided by 76. Okay, in total if you do total number of moles in the solution, if you do, then that's going to be 25 by 60 plus 25 by 76. That's it. Next, you can apply the formula delta TB. Okay, delta TB is going to be definitely TB minus TB naught. TB naught, that's going to be molality, right? Molality means number of moles of solute. So number of moles of solute we can write in terms of N total. Okay, N total into 1000 divided by weight of the solvent. Okay, So now let's put the value, put everything over here. So TB you have to find out, right? Minus TB naught you can directly write 61.2. Okay, that is equals to I forgot to write here the KB. Wait. TB minus TB naught equals to KB into this, right? Now KB value if I put here, that is 3.63 into, in total we are getting something 25 by 60 plus 25 by 76 into 1000 divided by weight of the solvent. Weight of the solvent is how much? 500 gram of chloromethane. So 1000 divided by 500. Okay, so from here if you just calculate TB, you will get your answer in some degree Celsius. Okay, because here I did not change the unit, I kept it in degree Celsius only, so you will get your answer in degree Celsius as well. I guess you understood this. I did not do the calculation here. You can do the calculation here and you can just directly put it into the equation as well. So your answer will be something 66.616 degrees Celsius. I guess this is clear to you. Let's go ahead. Calculate the osmotic pressure in pascals excreted by a solution prepared by dissolving 1 gram of polymer of molar mass this into 450 ml water. This is a very important problem for this year. Okay, let me just do it for you. So what are the things given at first? Weight of the solute, that is W2, it is basically 1 gram. Okay, molar mass of the solute M2, that is also given 185,000 gram per mole, right? Now volume also given, volume of the solution is also given 450 ml. Okay, temperature is given how much? 370 of water at 370 degrees Celsius. Okay, 370. Okay, degree Celsius means you have to convert it into Kelvin. So 273 plus 370. Okay, 643 Kelvin. Fine, let's go ahead. We have the formula pi equals to CRT. Okay, pi is the osmotic pressure here, C is the concentration. So concentration term we can break down in the form of number of moles. Okay, number of moles further can be divided, let's say W2 by M2 into 1000 into volume. Okay, into R into T. Okay, so W2 is going to be something 1 gram, right? Into 1000 divided by molecular weight is given as 185,000 into volume is 450 ml, right? Into R value, see overall it will come up to be liter. Okay, so if you have to put the R value, then you have to take the liter atmosphere unit. Okay, so liter atmosphere unit is basically 0.0083. Okay, into 643 Kelvin. So from here liter atmosphere per Kelvin. Okay, so everything will be cancelled out here and you will get the pi value in atmosphere. Okay, so from these particular value, if you just multiply 10 power 5, you will end up with the Pascal value as well. Okay, so let's see. So here you can see 64.106 kilopascal you will end up with. Okay, I guess this is clear to you. Let's go ahead. Calculate the concentration of that solution of sugar which has osmotic pressure 2.46 atmosphere at 300 Kelvin. Okay, let's do it. So for this case, what they said, osmotic pressure pi, that is 2.46 atmosphere, right? Okay, temperature how much? 300 Kelvin. Okay, now we can put it here, pi equals to CRT, right? So from here 2.46 atm is basically equals to C into 0.0083 liter atmosphere per Kelvin into 300 Kelvin. So here you can see Kelvin will be cancelled out. Okay, atmosphere both side will be cancelled out. Okay, so as a result of this you will get something C value is coming how much? It should be 2.46 divided by 0.083 0.00 sorry, 1 0 should be cancelled out, sorry, 0.0083. okay, 0.0083 into 300. okay, so if you just go ahead with this, so if you just multiply the molecular weight of sugar, that's going to be 342, right? 342, you will end up with the gram per liter unit. Okay, so you can check, the answer will come up to be something like 33.78 gram per liter. Okay, so I guess it is clear. Initially you will get it in mole per liter, but now once you will put the, you will multiply this with the molecular weight, here basically gram per mole. Okay, so you will end up with the gram per liter unit. I guess this is clear to you. Okay, let's go ahead. Calculate the molar elevation constant of water, it being given that 0.1 molar aqueous solution of a substance boiled at this temperature. Okay, let's go ahead. What are the given things? Molality is given, right? That is how much? 0.1 molar, 0.1 molar. Okay, TB is given, boiling point is how much? 100.052 degrees Celsius. Fine. Okay, TB naught for water, it's definitely going to be 100 degrees Celsius for pure water. Okay, so delta TB is something TB minus TB naught. Okay, so if you just put the value here, that is going to be Kb into m, right? So if you are just going to put the value here, so 100.052 minus 100 degrees Celsius, 100 degrees Celsius, wait, 100 degrees Celsius is going to be, what is the value of Kb? Kb you have to find out actually, Kb into 0.1. So if you calculate the Kb out of here, you will get the answer. Okay, so here you can see your answer of Kb is going to be 0.52. Okay, because here you can see, no, let me just do it, this calculation is way too simple actually. So from here I will get 0.052, from here divided by 0.1, that is the Kb value. So Kb is definitely is going to be 0.52. Okay, that's going to be, unit is going to be Kelvin mole inverse kg. I guess this is clear to you. Yeah, let's go ahead. The boiling point, it's a very important question actually. Okay, for this year. Okay, what they are asking? The boiling point of benzene is 353.23 Kelvin when 1.80 gram of a non-volatile solute was dissolved in 90 gram of benzene. The boiling point is raised to 354.11 Kelvin. Calculate the molar mass of the solute. Kb is also given. Fine. So let's do it. Direct application of the formula. Okay, so see what are the given thing. Let's write TB naught is given, that is 353.23 Kelvin. Okay, TB is also given. TB is also given, that is 354.11 Kelvin. Okay, Kb value is also given. Kb is basically 2.53 Kelvin kg per mole. Okay, next W2 is also given for the solute, right? They are saying 1.8 gram, right? So 1.8 gram. Okay. Next, molecular weight of the solute, that you have to calculate. Okay, molecular weight of the solute you have to calculate. Okay. Next, W1, that is the weight of solvent, that is given 90 gram. It is also given 90 gram. Okay. Yes, I guess we are having everything. Okay, let's put it into the formula. So delta TB is going to be TB minus TB naught, right? So that's going to be equals to KB into M. M we can write, molality we can write it as W2 by M2 into W1 into 1000. Let's substitute here everything. So 354.11 minus 353.23. Okay, here KB we will put 2.53. Next, okay, let's write the unit as well, Kelvin. Anyway, molecular weight it will come up to be gram per mole. Okay, so Kelvin, kg, mole inverse. Fine. Now W2 is given as 1.8 gram. M2 you have to find out, right? Into 1000, here into 90 gram, right? So if you just calculate this entire thing, okay, you will get your answer. You have to calculate the M2, right? It will come up with gram per mole unit. Okay, so you will end up with 57.5 gram. Okay, I guess this is clear to you. Let's go ahead. A solution containing 34.2 gram of cane sugar dissolved in 500 centimeter cube of water froze at minus 0.374 degrees Celsius. Calculate the freezing point, depression constant of water. Okay, let's do it. So what are the things that are given? At first write it. So weight is given, weight of cane sugar, that is given how much? 34.2 gram. Okay, molecular weight we know, that is 342 gram. Okay, now see here dissolved in 500 centimeter cube of water they are saying. Okay, so from here density of water we know 1 gram per mole, right? Okay, so from here weight of water, that also I can get 500 gram, right? Because D equals to M by V, so M equals to V into D. If you do, then you will get 500 gram, right? So now freezing point TF also is given of the solution, that is minus 0.374 degrees Celsius. Fine. Now TF naught we already know for water, that is 0 degrees Celsius. Fine. Okay, now let's put everything into the formula. So what is the formula? Delta TF is basically TF naught minus TF is basically equals to KF into molality, right? So molality if you find out, that is W2 by M2 into W1 into 1000. Okay, so let's put everything here. So 0 minus of minus 0.374, okay, that degree Celsius equals to KF, that you have to find out actually. Here W2 is given as 34.2 divided by 342 gram per mole into water weight is 500 gram here and here 1000. Okay, so if you just calculate the KF out of this, okay, you will get your answer. Okay, you have to find out the KF. So I guess this is clear. It will come up to be something 1.87. Okay, so I guess this is clear. Let's go ahead. The solution of urea in water has boiling point this. Calculate the freezing point of the same solution. Molar constant of water Kf and Kb is also given. Okay, so what they have given? Boiling point of water, that is, let's say Tb naught, let's take Tb naught is given as 100 degrees Celsius. Okay, now Tb is given how much? 100.128 degrees Celsius, right? So now what do you have to do? Freezing point also we know. All of them for water, huh? All of them for water. All of them for water. Freezing point of water we know 0 degrees Celsius. Okay. Freezing point of urea solution, that is TF, that solution that we have to find out. Okay, that we don't know. Okay, so how you should go ahead? Kf also is given. Okay, Kf how much? 1.86. Okay, and Kb is also given as 0.512. Fine, let's go ahead. So from here I can do the ratio delta TF divided by delta TB. Okay, so for this particular case it's going to be TF naught minus TF divided by TB minus TB naught. Okay, so molality will be cancelled out and here I will get Kf by Kb. Fine. So now what we have to do is just put the value here. So TF naught is going to be 0 minus TF we have to find out divided by TB we know 100.128 minus 100 degrees Celsius, okay, equals to Kf value we know 1.86 divided by Kb value also you know 0.512. Okay, so from here if you just a little bit, let me just go ahead with the calculation, that is minus TF, right? Minus TF from here is divided by 0.128 is basically equals to 1.86 divided by 0.512. So from here TF you will get minus of 1.86 into 0.128 divided by 0.512. That's it. If you just do this you will end up with something negative degree Celsius. Okay, so you can see minus 0.465 we will get. Okay, I guess this is clear to you. Let's go ahead. Okay, let's go ahead with the next problem. Two elements A and B form compounds having the formulas AB2 and AB4. Fine. When dissolved in 20 gram of benzene, 1 gram of AB2 lowers the freezing point by 2.3 Kelvin, whereas 1 gram of AB4 lowers it but by 1.3 Kelvin. The molar depression constant of the benzene is also given. Calculate the atomic mass of A and B. Okay, this is a seriously tricky problem and it can be considered as HOTS. Okay, so yeah, let's go ahead. We will take something, we will assume something. Let the atomic weight of A, let it be x gram. Okay, x gram, and for atomic weight of B, let it be y. Okay, so now for AB2, for the first one, okay, what are the given thing that we will write first? W2 is given, means how much weight of AB2? 1 gram, right? So weight of AB2 is given, that is 1 gram. Okay, molar mass. So M2 how you will find out? 1A means x plus 2y, right? That will come. Okay, now what they have given? Weight of benzene also given, W1 is also given, that is how much? 20 gram. 20 gram. Okay, delta TF also given, delta TF is given as 2.3 Kelvin. Okay, Kf is also given. Kf is also given. Kf for the, okay, 5.1. That is 5.1. Okay, let's go ahead. Definitely you can write the unit here. I'm just not going to do it in a difficult way. That's it. Okay, so let's go ahead. So if you just put the formula here, delta TF is basically going to be Kf into M. Okay, so from here I can write Kf into molality. If I just split W2 by M2 into 1000 divided by W1. Everything you put here, so it's going to be TF value is 2.3, right? 2.3 equals to Kf. If I put 5.1, okay, then this W2, M2, everything we will put from here. W2 is 1 gram, okay, divided by M2 is basically X plus 2Y into 1000 divided by molecular weight of benzene, sorry, given weight of benzene, that is 20 gram. So this is something like this. Okay, so now if I just simplify this, I will get something like, see, X plus 2y value I need basically. So this is going to be something 5.1 divided by 2.3 into 1000 by 20. Okay, so this is something your x plus 2y value. Okay, let it be your equation number 1. Actually we can find out the value, just a minute. If you just find out the value, it should give you 110.86. Okay, so this is, let's say, your equation number 1. Okay, next one more equation we will get for AB4. Okay, so for AB4 we will do the same thing. Okay, so here again, you know how much delta TF value was. Okay, let's write one by one. W2 is basically 1 gram, similar, right? Next, M2 is going to be A means X plus 4Y, right? Next we will get W2, M2 is done. Then benzene, we know W1 is also given, that is 20 gram. Okay, delta TF, that is given here. Let me check here. How much? 1.3. Okay, let's go ahead. This is 1.3. Now let's put everything together. Okay, so delta TF basically equals to KF into W2 by M2 into 1000 divided by W1. Okay, let's go ahead. Delta TF is given as 1.3 equals to 5.1, probably the KF value. Let me check once. Yes, 5.1. 5.1. Okay, here W2 is 1 gram as usual. Okay, divided by X plus 4Y into 1000 divided by W1. W1 is how much? 20 gram of benzene was there, right? So if I just simplify the calculation a little bit, you will get X plus 4Y is equals to 5.1 divided by 1.3 into 1000 by 20. Okay, so let me just do the calculation for the simplification. Okay, so that's going to be 196. That's going to be 196. Okay, so this is your equation number 2. Okay, so now you have equation 1, equation 2. So if you solve these two equations, this is your equation 1. Another one equation was something X plus 2Y is equals to 110.86 equals to 110.86. Okay, so if you just solve these two equations, your x value will come, your y value is come. So x is the molecular weight of A and y is the atomic weight, and this is also atomic weight of B. Okay, so if you just calculate this, you will get it. Okay, if you just solve these two equations, so you will see you will get 25.59 and for B you will get 42.64. Okay, I guess this is clear, a little bit tricky one, but it's a good problem. Okay, let's go ahead. Okay, let's begin with the chapter Electrochemistry. Okay, so let's go ahead with the Electrochemistry chapter. So here comes the first problem. The resistance of a 0.01 normal solution of an electrolyte is 100 ohms. Calculate the conductance, conductivity, resistivity. The cell constant is 1 centimeter. Okay, so okay, let's go ahead. So first we have to find out the conductance, that is G. G is basically 1 by R, we know. Okay, so from here we can directly get 1 by 100 ohm. Okay, so from here 10 power minus 2 ohm inverse. Okay, next B, we have to find out the conductivity. Okay, fine. So basically R equals to, we know, rho into L by A. Fine. So from here, if I just take the reciprocal, 1 by rho, that is the conductivity, is basically equals to 1 by R into L by A. Okay, so from here kappa is going to be 1 by R into L by A. So now let's put everything over here. So 1 by R we have already calculated, that is 10 power minus 2 into L by A is nothing but the cell constant, it is going to be centimeter. Okay, centimeter, I guess it's clear, centimeter inverse basically. So kappa from here I am going to get 10 power minus 2 Simon centimeter inverse. Okay, so conductivity also we got. Next, resistivity. Okay, so resistivity is basically rho. So rho is basically 1 by kappa, right? So 1 by kappa in the sense 1 by 10 power minus 2 Simon centimeter inverse. So from here you will get how much? 10 square. 10 square. Simon means ohm, right? Ohm centimeter. That's it. Okay, I guess you understood this. It's a very simple basic problem. Write the formula, put the values and you will get it. Okay, I guess this is clear to you. Yes. Okay, let's go ahead with the next problem. The standard cell Cu2 plus Ag plus Ag. Okay, E0 of Cu2 plus Cu is given. E0 of Ag plus Ag is also given. Identify the cathode and anode as the current is drawn from the cell. So for this case, let me write the first one by one answer. Anode means you have to check where the oxidation takes place. Okay, so for this particular case, the value of the E0 should be the lesser one, right? So it's going to be the copper one. Okay, next cathode definitely is going to be silver. Okay, so next write the reaction. Okay, anode reaction, let's write. Anode reaction, if I write, that is Cu2 plus will takes up 2 electron and it will get converted to Cu. Okay, and cathode reaction, if I write, that is basically Ag plus will takes up 1 Ag will give Ag. Fine, this is the reaction. Now what do you have to find out? Third, calculate the standard cell potential. Okay, so standard cell potential, how you should get it? E0 of cell is going to be E0 of cathode minus E0 of anode, right? So yes, let's put the value 0.8 minus 0.34. So whatever it will come, that is the answer. Okay, you should get 0.46. Okay, 0.46. Okay, I guess this is clear to you. Okay, let's go ahead. Calculate the potential of hydrogen electrode in contact with the solution whose pH is 10. Okay, so very nice problem basically. So see, from the pH value we will get the concentration of H plus. So here you can see what is the equation, what is the reaction going on. 2H plus, it will takes up 2 electron to give you H2. Okay, so now let's write the nonce equation. E cell equals to E naught cell minus 0.059 divided by 2 log 1 by H plus whole square. Okay, so now let's put E0 cell for the hydrogen. We know it's 0 minus 0.059 divided by 2 log 1 by, okay, concentration of H plus square. So as you can see, pH equals to, pH is 10, right? So pH is 10, it means what? pH is 10 means minus log of H plus is basically 10. So from there, concentration of H plus, if I calculate, it's going to be 10 power minus 10. Right? So from there, let me just write the same thing, 10 power minus 10 whole square. Okay, so if I just continue, 0 minus 0.059 divided by 2 log, here it will come as 10 power 20. Okay, so I will get minus 0.059 divided by 2 into 20. Right? So now if you just calculate this thing, this will give you 10, you will get minus 0.59 volt. Okay, so let me check. Yeah, this is the answer. Okay, I guess this is clear to you. Let's go ahead. Okay, calculate the EMF of the cell in which the following reaction takes place. Okay, so this is a very, very important problem. Okay, so for this year, okay, let me just do this. E cell is basically equals to E naught cell minus 0.059 by 2 log product by reactant. So Ni2 plus divided by Ag plus whole square. Ag plus whole square, right? Okay, let's everything we will put here. That is E0 cell value is also given, that is 1.05, okay, minus 0.059 divided by 2 log, let's put the value concentration term, that is 0.16 divided by 0.002 whole square. Okay, so yeah, let's go ahead. 0.002 whole square means, let me write it directly. I will get it something like 4 into 10 power minus 6 I will get, right? Okay, so let's go ahead. 1.05 minus 0.059 divided by 2 into log, here I will get 4 into 10 power 4 I guess. Yeah, 4 into 10 power 4 I will get. Fine, let's go ahead. Okay, 1.05 minus 0.059 divided by 2. So if you just find out this is see, log 4 plus, let me just do it here, log 4 plus 10 power 4, right? So log 4 means I can do 2 into log 2, okay, plus 10 power, sorry, plus log 10 4, okay, so plus 4, okay. So from here 2 into 0.301 plus 4, that's what we can do here. Okay, so let's go ahead. So if you multiply that, what it will come? It will come up to be 0.602 plus 4. Okay, I'm not going for a detailed calculation further, you can do it Okay, your answer will come up to be 0.91 volt, 0.91 volt. Okay, I guess this is clear for you. Yeah, let's go ahead. Okay, the cell in which of the following reaction occurs? Okay, the cell in which of the following reaction occurs? Fe3 plus I minus will give you Fe2 plus I2. Okay, E0 cell value is given. Calculate the standard Gibbs energy change and the equilibrium constant for the cell. Okay, so easy formula, delta G is basically equals to minus NF E0 cell. Okay, so let's put the value. For this case, 2 electron exchange, minus 2 into F value is 96500 into E0 cell is how much? 0.236, 0.236. Okay, whatever the answer you will get. So you can see Gibbs free energy is minus 45.55 something kilojoule you will get. Okay, fine. Let's go ahead with the next problem, that is a equilibrium constant. So how you will do it? E0 cell is basically equals to 0.059 divided by n into log k. Okay, that is the problem. So E0 cell, let's put it here, 0.236 equals to 0.059 divided by 2 into log k. K you have to find out. Okay, so 0.236 into 2 divided by 0.059, okay, equals to log k. Okay, so if you do this side, okay, if you do this side, your calculation should come up to be almost 8. Okay, 8 equals to log k. So from here k will be something 10 power 8. That's it. Okay, I guess this is clear to you. Let's go ahead. Okay, the molar conductivity of 0.25 mole per liter methanoic acid is 46.1 Simon centimeter square mole inverse. Calculate the degree of dissociation and dissociation constant. Given lambda 0 for H plus and lambda 0 for CHO minus. Okay, fine. Let's go ahead. So, see, lambda M0 for methanoic acid means HCOOH, right? It is basically lambda M0 of HCOO minus plus lambda M0 of H plus. Okay, so for this case we can just simply add them. So 54.6 plus 349.6, okay, Simon centimeter square mole inverse. How much you will get here? You should get something 2.2404. Okay, this Simon centimeter square mole inverse you should get like this. Okay, fine. Now what you have to do? So alpha you have to find, that is the dissociation constant, that is basically lambda m by lambda naught m. So lambda m value is something going to be okay, wait, this is one decimal, we missed it, I guess. 0.2 it should come. Okay, so yeah, let's go ahead. Lambda m value you can get from the question, molar conductivity, it's 46.1, right? So you are having 46.1 divided by 404.2, right? So from here I'm not calculating now. So now from here see, this will give you the alpha, degree of dissociation. Okay, now dissociation constant, in order to find out k is basically C alpha square. C value is given, concentration 0.025, okay, into 46.1 divided by 404.2. If you do this, you will get the k value as well. Okay, so you can see alpha will come up to be something 0.144. Okay, K value will come up to be 3.67 into 10 power minus 4. So you should proceed with this method. Okay, I guess this is clear. Let's go ahead. If a current of 0.5 ampere flows through a metallic wire for 2 hours, then how many electrons flow through the wire? Okay, so it's a very important question as well. Okay, let's go ahead. So Q is basically equals to I into T. Okay, so let's put the value here, 0.5 ampere, right? 0.5 ampere for how many hours? 2. So we will take it into second. Okay, so 2 into 60 into 60. Okay, so how much you will get? 0.5 into 2, 1. Okay, so you will get 3600. Okay, so now we know Q equals to N into E, right? So for N is basically equals to Q by N, sorry, N is basically Q by E, Q by E, right? So from here I can write 3600 divided by the charge of 1 electron 1.6 into 10 power minus 19. Okay. Okay, so if you just calculate this, you will get the number of electron answer. Okay, so you will get 2.246 into 10 power 22 here. Okay, I guess it is clear to you. Let's go ahead. Okay, the resistance of a conductivity cell containing 0.001 molar KCl solution at 298 Kelvin is 1500 ohm. What is the cell constant if the conductivity of 0.001 molar KCl solution at 298 is 0.146 10 power minus 3? Okay, so this is also not that much difficult. We can just go ahead with the resistance formula. Is basically rho into L by A. So from here I can get L by A is basically R by rho. Okay, so from here I can get R into kappa because 1 by rho is kappa. Okay, so from here cell constant, this L by A is nothing but the G star, right? So G star is coming up something like 1500 ohm into, what is the conductivity? 0.146 into 10 power minus 3 Simon centimeter inverse. So overall it will come up to be a centimeter inverse. Okay, so your answer should come up to be something like 0.219 centimeter inverse. Okay, I guess this is clear to you. Yeah, let's go ahead. Okay, how much electricity in terms of Faraday is required to produce 20.0 gram of calcium from molten calcium chloride? Okay, one by one let's do. So basically for this case, first problem, let's write the equation at first. Ca2 plus 2 electron will give you Ca, right? So you need 2 electron, right? So from there you will get, so 1 electron means 1 electron charge is 1 Faraday. Okay, so 2 electron charge means 2 Faraday, right? So from there you will get it. So 40 gram will need require 2 Faraday. Okay, from there if I have 20 gram, so definitely it's going to be 2 by 40 into 20. Okay, so definitely that's going to be 1 Faraday. Okay, so 1 Faraday charge will be required. Okay, I guess this is clear for you. Let's proceed with the second part, that is aluminium 3 plus will takes up 3 electron to give you aluminium, right? So now aluminium molecular weight is 27 gram. So 27 gram will require 3 Faraday charge because 3 electron exchange you can see. Now how much is given? 40 gram. So 40 gram will require 3 by 27 into 40. Okay, so your answer should come up something like something Faraday. Okay, you can see your answer is basically, your answer is basically 4.44. Okay, So 4.44 Faraday. I guess this is clear to you. Okay, let's go ahead. A solution of nickel nitrate is electrolyzed between platinum electrodes using current 5 amperes for 20 minutes. What mass of nickel is deposited at the cathode? Okay, let's go ahead. So we can use the formula M equals to Z into I into T. Okay, so now Z we can write, this is basically electrochemical equivalence, right? So that is molecular mass divided by number of electrons into Faraday, that is 96500 into I into T. Let's put the value everything over here. How much weight nickel nitrate? 58.6 divided by 2 is the number of electron gets transformed, because you can see nickel 2 plus charge will form, into 96500 into, okay, so they are saying 5 amperes, so I is 5, time they are saying how much? 20 minutes, so 20 minutes into 60 seconds. Okay, so if you just go ahead with this, you will get the mass about it. Okay, so you can see your mass should come up as 1.825 gram. That's it. Okay, I guess this is clear to you. Let's go ahead. Okay, let's go ahead with the next problem. An electric current of 100 ampere is passed through a molten liquid of sodium chloride for 5 hours. Calculate the volume of chlorine gas liberated at the electrode. Okay, fine. So what we have to start with? We have to start with like calculation of charge. So charge is basically equals to I into T. Okay, so I is 100 ampere, right? 100 into time is given as for 5 hours. So 5 into 60 into 60. Okay, so how much you will get here? 180000. Okay, this much coulomb. Okay, so now if you just write the equation, sodium chloride, right, minus means Cl minus is present, so Cl minus will form Cl2 plus 2 electron it will give. This is the liberated chlorine, so you can see 2 unit of electron. Okay, so how much charge from the electron means 2 Faraday, right? So from here I can write 2 into 96500 coulomb, 2 coffee. Okay, 2 into 96500 coulomb will give you 1 mole of chlorine, 1 mole of Cl2. Okay, hence how much charge I got? 181, how many 0? 1, 2, 3, 4, 5. This much coulomb is will be something 1 divided by 2 into 96500 into 185. That's it. Okay, so if you just calculate this, your answer will come here. Okay. Okay, so basically wait, here it will come up to be 1 mole. You have to convert it into liter, right? So because it is given in NTP, right? So that's why you can multiply this with 22.4 liter. Okay, so as you can see, the answer also it came up to be something liter. Okay, so I guess this is clear to you. So volume of chlorine, that must be come up into the liter unit. Okay, this will come up in the mole. Okay, then if you multiply this into the liter unit, then you will get the answer in liter. Okay, I guess this is clear. Let's go ahead. Okay, let's go ahead with the next problem. Here you can see, in an electrolysis experiment, a current was passed for 5 hours through 2 cells connected in a series. The first cell contains a solution gold salt and second cell contains copper sulfate solution. 9.85 gram of gold was deposited in the first cell If the oxidation number of gold is +3, find the amount of copper deposited on the cathode. Okay, so here we can use the Faraday's law, right? So mass of copper divided by mass of gold equals to equivalent weight of copper divided by equivalent weight of gold. Okay, so yeah, mass of copper you have to find out. Okay, mass of copper you have to find out. So equivalent weight of copper into mass of gold divided by equivalent weight of gold, that will give you the answer. Okay, so I have to find out the equivalent weight of copper and gold. Okay, so for copper, molecular weight of copper is 63.5. okay, in gold salt, in copper sulfate, copper oxidation state is +2, so that is going to be 63.5 divided by 2. Okay, so for gold, this is for equivalent weight of copper. Okay, now equivalent weight of gold, if I find out, gold is basically 197. Okay, and you can see +3 oxidation state that they told, so divided by 3. So let's put everything here. So if you just put this 63.5 divided by 2, and here 197 divided by 3, here mass of gold how much? 9.85, 9.85. okay, so if you do this, you will get your answer. Okay, your answer should be 4.76. okay, let's go ahead. How long has a current of 30 ampere to be applied through the solution of a silver nitrate to coat a metal surface of 80 centimeter square with 0.005 centimeter thick layer? Okay, density is also given. Okay, so for this case, what we can do is, we can find out the volume at first. Okay, so volume, they are saying metal surface. Surface means this is the area, that is 80 centimeter square, into length. Length is how much? They are saying 0.005 centimeter. Hence, we can write it as 5 into 10 power minus 3 centimeter. Okay, so if you do this, how much it will come? It will come up to be 400, right? 400 into 10 power minus 3 centimeter cube. Okay, let's make it shorter, 0.4 centimeter cube. Okay, so volume we got. Now we know D equals to m by V, density equals to mass by volume, right? So from here I can calculate mass. Okay, so mass is going to be density into volume, so 0.4 centimeter cube into density is how much it is given, you can see 10.5 gram per centimeter cube. Okay, so if you just do this, it will come up to be 4.20 gram. Okay, I guess this is clear. Okay, no, it's not yet done. Mass we got. Okay, so how long? You have to find out the time. So how you should get the time from here? See, from here I can do m equals to z into I into t. So mass I got something 42. Okay, wait, 2 decimal, no, 4.2, right, equals to z for the silver, molecular weight divided by the factor, n factor is going to be 1 here. So 108 into divided by 1 into 96500, this is z, into I is how much? 3 ampere, right? T you have to calculate. Okay, so if you calculate the T, you will get your answer from here itself. Okay, your answer should come up with 125.09 second. Okay, I guess this is clear to you. Yes, let's go ahead. Okay, a saturated solution of silver chloride at 20 degrees Celsius has conductivity of 3.41 into 10 power minus 6 Siemens centimeter inverse. The conductivity of water used as 1.60 into 10 power minus 6 centimeter per Siemens per centimeter. Determine the solubility of silver chloride in moles per liter. Okay, molar conductivity is also given. So this is also a very tricky problem. Okay, let's go ahead. Okay, so conductivity of AgCl. If I want to find out, so definitely that's going to be conductivity of AgCl solution minus conductivity of water. Right. So if I just put the value from that question, that is 3.41 into 10 power minus 6 minus for water is 1.6 into 10 power minus 6. If you take 10 power 6 common, so 1.6 3.4 minus 1.6, right? Okay, this is 1.81 into 10 power minus 6 Siemens centimeter inverse. Okay, so kappa of AgCl we got. Now lambda m we have to find out, right? So lambda m is basically equals to kappa into 1000 divided by C. C actually we need. Lambda m value is given here, molar conductivity 138.3 equals to, let's put the value of kappa from there, 1.8 into 10 power minus 6 into 1000 divided by C. So you have to find out C basically. Okay, so C if you calculate, then your answer should come up to be something like this mole per liter. I guess this is clear. Let's go ahead. Okay, calculate the quantity of electricity that would be required to reduce 12.3 gram of nitrobenzene into aniline if the current efficiency of for the process is 50%. Potential drop across the cell is 3 volt. How much energy will be consumed? Okay, let's do it. Okay, so this particular problem is basically falls under the HOTS. Okay, it's a really tricky one and difficult one as well. So let's do the reduction of aniline at first. Let's see how many moles of electron you need. So this is your NO2. Okay, NO2 gets converted to NH2. Right? So in order to balance this equation, so here I have total 2 oxygen, so I can put 2H2O here. So 2H2O means total how many hydrogen comes? 6 hydrogen, so 6H plus, right? 6H plus. To balance it, I am adding 6 electron. Redox method, ion electron method I applied here, nothing else. Okay, so 6 electron I need here. Okay, 6 electron means I can get 6 Faraday. 6 Faraday charge is required. Okay, so what is the molecular weight of nitrobenzene? So if you calculate the molecular weight of nitrobenzene, it comes up to be something like, just a minute, it will come up to be something like 123 gram. Okay, so from here what information I am getting? 123 gram of nitrobenzene, C6H5NO2, it requires 6 Faraday charge, right? Okay, let me write it clearly. NO2, it will require 6 Faraday charge. Hence, 1 gram, directly we can write 12.3, right? 12.3 gram of nitrobenzene will require 6 by 123 into 12.3. Okay, so that will give you how much? That will give you 0.6 Faraday. Okay, So I guess up to this is clear. Okay, so this much Faraday is required, but they are saying here something else. The current is 50% efficient. You can't give 0.6 Faraday. Okay, so how much you give so that you will get 0.6 Faraday? So definitely, as you can write from here, since current is 50% efficient, hence we have to provide 1.2 so that it becomes 0.6, because 0.6 is required, right? So we have to provide 1.2 Faraday, right? So what is the total charge coming? Means charge equals to 1.2 into 96500 Coulomb, right? Okay, so this is the thing. Okay, so now if you find out the energy, that is basically potential drop into quantity of electricity. Okay, so from here potential drop is how much? They are saying it is, potential drop is basically 3, right? 3 volt. Okay, so that into 1.2 into 96500, so that will give you the answer. Okay, so you can see the energy should be see EMF into quantity of electricity, so you will get 347 into 400, something like that. Okay, so I guess it is clear for you. Okay, so from here actually you can find out the Q value. Okay, I guess this is clear. Let's go ahead. Let's go with the next problem. Two students use the same stock solution of zinc sulfate and the solution of copper sulfate. The EMF of one cell is 0.03 volt higher than the other. Okay, the concentration of copper sulfate in the cell with higher EMF value is 0.5 molar. Find out the concentration of copper sulfate in other cell. Okay, fine. This is a basically HOTS level question. It's really difficult. So you have to just find out the EMF of two different cell. Just subtract the value and you will get it. You can see E value is given as 0.03, right? And if I just take the 2.303 RT by F value common outside, so it should be minus 0.06 divided by 2, right? Because both the cases the valency will come up as 2. Okay, now it will be of log Zn2 plus by Cu2 plus minus log Zn2 plus by Cu2 plus, two different solution. Okay, I guess this is clear. Let's write it like how I should represent it. This is for the second solution, this is for the first one. Okay, so yeah, let's put the value here. So here you can see this will also come up to be 0.03. Okay, so you will get minus 1. I am taking minus 1 that side. So for this case, let's take first case, log Zn2 plus and log Cu2 plus minus log Cu2 plus. Okay, so this is basically your 2, right? This is basically your 2 minus log Zn2 plus. Zn2 plus is quite similar, log Zn2 plus log Cu2 plus. This is the first solution, right? So from here you can see log Zn2 plus, log Zn2 plus Zn2 plus will be cancelled out, right? So from here you will get minus 1 equals to minus 1 equals to I am getting log Cu2 plus first solution minus log Cu2 plus second solution. Okay. So from here what you can do is minus 1 equals to log concentration of Cu2 plus in the first solution divided by second solution, or you can go away with the original solution. Okay. Okay. So yeah, let's put the value here. From here if I further proceed, that is minus 1 is basically equals to, so if I just put the value here, Cu2 plus concentration is given how much? Stock solution of zinc sulfate, okay, 0.5 molar, right, 0.5 molar is given. Okay, so that is log, okay, let me just take it this side, anti-log let me do here itself. So it will come up to be something like 10 power minus 1, right? 10 power minus 1 is basically Cu2 plus 1 divided by 0.5. Okay, so from here concentration of Cu2 plus that I am getting is 0.05 molar. Okay, yeah, that's the value. Let me check. Yeah, that is the answer. Okay, I guess this is clear. Let's go ahead. Here you can see, show that 0.08 molar solution having conductivity equal to 10 power minus 2 ohm inverse centimeter inverse has higher molar conductance than 0.10 molar solution having the resistivity equal to 58 ohm centimeter. Okay, let's go ahead. We have to find out the molar conductivity for both the cases. Fine. For first one, for the first solution, so kappa is given, right? Kappa is given how much? 2 into 10 power minus 2 ohm inverse centimeter inverse, right? Concentration is also given. Concentration is how much? 0.08 molar. Okay. So lambda m we can calculate 2 into 10 power minus 2 into 10 cube means 1000 divided by concentration, that is 0.08. Fine. So if you calculate you will get some answer. Okay, we will do it later. Next, for second case, if you see kappa value is given, not given basically, resistivity they told, means 1 by 58 we can take. 1 by 58 we can take. Okay, so lambda we will now put, lambda is something like, lambda will be lambda m something like kappa, that is 1 by 58 into 10 cube divided by, what is the solution? 0.1 molar. So 0.1 molar. Okay, so if you just calculate this, okay, so if you just calculate this and compare, you will get it. Okay, so let me just tell you, okay, that values are not here, wait. Okay, so for this case the values are basically wait, you will get 250 Simon centimeter square mole inverse. Okay, and for the second case you will get something 172 Simon centimeter square mole inverse. So you can see first one is more, molar conductivity is more than that of the second one. Okay, I guess clear. Let's go ahead. The molar conductivity of acetic acid solution at infinite dilution is 390.7 ohm inverse centimeter minus 2 per mole. Okay, calculate the molar conductivity of 0.01 molar acetic acid solution given that the dissociation constant of acetic acid is this. Okay, this is also a HOTS type. Okay, difficult one. Okay, let's go ahead. Okay, so lambda m0 is given. Lambda m0 value is how much? 390.7 ohm inverse centimeter per centimeter square mole inverse. Fine. So now concentration is also given for the solution acetic acid 0.01 molar. Okay. Anything else is given? Dissociation constant means Ka is also given, that is 1.8 into 10 power minus 5. Fine. What do you have to find out? We have to find out basically lambda m, molar conductivity. Okay. So how we should proceed? Alpha is basically equals to lambda m by lambda m0, right? So, and how should I find out alpha now? So from the Ka is basically C alpha square, right? So from here alpha is basically equals to under root Ka by C. Okay. So now let's put this here. What I will get? Alpha is basically equals to, sorry, wait, if I just take it as equation 1 and if I take it as equation 2, then we can compare the equations. Okay, so how should I compare? Lambda m divided by lambda m0 is going to be under root Ka by C. Okay, let's put the value here. Lambda m we have to find out. Lambda m0, it's there, 390.7 equals to Ka value is also given, 1.8 into 10 power minus 5 divided by C is also given, that is 10 power minus 2. Okay, so if you calculate this, you will get your lambda m value. Okay, so you can check, it will come up to be something like 16.57 ohm inverse centimeter power minus 2. This is the answer you will get. Okay, I guess this is clear. Let's go ahead. Okay, how many grams of chlorine can be produced by electrolysis of molten sodium chloride? The current of 1 ampere for 15 minutes. Okay, also calculate the number of chlorine molecules liberated. Let's go ahead. Okay, so first let's write the reaction. What is the reaction? Sodium chloride, right? So molten sodium chloride. So 2Cl minus will be converted to Cl2 plus 2 electron. So how much Cl2? 1 mole. 1 mole means how much? 71 gram. Okay, and 2 electron you can see. Fine. 2 electron means 2 Faraday, right? 2 Faraday, right? Okay, so 2 into 96500 coulomb can give you 71 gram chlorine. Okay, hence, okay, I have to find out the charge as well. Let's do it at first. Q is basically equals to I into T. So I is basically given as 1 ampere into 15 minutes. So 15 into 60. So I am getting 900 coulomb. Fine. Now we can do it with respect to 900 coulomb. So this much will give me 71 gram chlorine. Hence 900 coulomb can give me 71 divided by 2 into 96500 into 900 gram. Okay. So this is the gram of chlorine. Okay, so from the gram you can calculate the number of moles. Let's say something W1 gram I got. Okay, so number of moles you will get, number of moles, how many you will get? So whatever the number you will get, that is W1 divided by the molecular weight. Okay, given weight by molecular weight. Okay, so basically if I just write the as it is W1 gram, so 71 into 900 divided by 2 into 96500, that is basically W1, right, into 1 by 71. So 71 will be cancelled out. 900 by 2 into 96500, that's it. That is the number of mole you will get. Okay, so number of chlorine molecules now you have to find out. So number of molecules, that is the number of moles of chlorine into Avogadro number. Okay, so number of moles of chlorine is how much? 900 by 2 into 96500 into 6.023 into 10 power 23. Okay, whatever the answer will come, that many molecule. Okay, so you can see that is the answer. Okay, so weight here you will get something like 0.331 gram. Okay, number of moles you will get 2.80 moles here, and molecules you will get something 2.80 into 10 power 21. Okay, I guess this is clear to you. Let's go ahead. Okay, so the lambda m0 value of NaCl and KCl are given. Okay, the ionic conductance of Na plus at infinite dilution is also given. Calculate the ionic conductance at infinite dilution for K plus ion. Okay, so that's an easy one. So see, lambda 0 of NaCl, so that's gonna be lambda 0 of Na plus plus Cl minus. Okay, so that is how much it is given? 126.5 Simon centimeter square mole inverse. Okay, so from another thing that is given, lambda 0 of KCl, right, that is also given lambda 0 of K plus lambda 0 of Cl minus, that is also given as something 149.9 Simon centimeter square mole inverse. Okay, so now you can put from here, what you can do is you can just put the value of NaCl. Lambda 0 of Na plus is given. Okay, so that is 50.1 Simon centimeter square mole inverse plus lambda 0 of Cl minus is basically 126.5, right, Simon centimeter, same unit will be there. So from there, lambda 0 of Cl minus, it should be 126.5 minus 50 lambda, minus 50.1 Simon centimeter square mole inverse. Okay, so whatever the answer will come, that is the answer. Okay, so let me tell you, for Cl minus, that answer is going to be 73.5 Simon centimeter square mole inverse. In the same way, we can calculate for the K plus as well from here. Okay, from that equation we can calculate. So lambda 0 of K plus, lambda 0 of Cl minus we got now 73.5. Wait, first calculate the ionic infinite dilution for the K plus. Wait, this is not 73, this is the final answer. Just a minute. So if you calculate this, your answer should come up to be something like here 76.4 Simon centimeter square mole inverse. Fine. Now we can put the value of lambda 0 of Cl minus, that is 76.4, right? That is equals to 149.9. Okay, so lambda 0 of K plus is going to be 149.9 minus 76.4. Okay, that will give you the answer 73.5. Okay, Simon centimeter square mole inverse. Okay, I guess this is clear now. Let's go ahead. Okay, so this is all about the 20 problems from the electrochemistry. So now we will go ahead with the chemical kinetics. Okay, so let's go ahead with the chemical kinetics. First numerical, the decomposition of N2O5 in CCl4 at 318 Kelvin was studied. Initially the concentration of N2O5 is 2.33 mole per liter, and after 184 minutes it was reduced to 2.08 mole per liter. Okay, the reaction takes place according to the equation. Fine. Calculate the average rate of this reaction in terms of second. What is the rate of production of NO2 during this period? Okay, so let's do it. Okay, so basically how you should find out the change in concentration of N2O5 from here? Change in concentration of N2O5 that we should find out earlier, that is concentration of N2O5 final minus concentration of N2O5 initial, right? So if you just put the value from the question, that is 2.08 minus 2.33 mole per liter, right? So if you calculate this, 5 2 minus 0.25 mole per liter it will come. Okay, now average rate if I calculate, so average rate in accordance to the formula differential rate equation, it will come up to be, see here I am having 2 as a stoichiometry, right? So minus half into change in concentration of N2O5 by delta T. Okay, so let's put the value here, minus 1 by 2. So this should be minus 0.25 mole per liter divided by change in time. What is the change in time? In how much time? I am having it in 184 minutes, right? So I have to convert this into second, so into 60, okay, second. So if you entirely calculate this, your answer should come up to be something like, if you entirely calculate this, 1.13 into 10 power minus 5 mole per liter per second. That's it. Okay, I guess it's clear to you. Let's go ahead. Now average, what we have to find out next, average rate of production of NO2. Okay, so rate of production of NO2, rate of appearance or production, rate of production of NO2, if I do, that is delta into change in concentration of NO2 with respect to delta T, right? So this is nothing but 4 into average rate, right? 4 into average rate. So that is going to be equal to, because 4 you can see this is the stoichiometry out there, okay? 4 into average rate, right? So if you just put 4 into 1.13 into 10 power minus 5, so your answer will come up to be something like 4.52 into 10 power minus 5 mole per liter. Okay, so I guess this is clear, mole per liter per second. Okay, mole per liter per second. I guess this is clear for you. Yeah, let's go ahead for the next problem. Okay, you can see a first order reaction is found to have a rate constant K equals to 5.5 into 10 power minus 4 second inverse. Find the half life of the reaction. Okay, so that's quite easier. So we know the formula of T half. So T half is basically equals to 0.693 divided by K, right? So just put the value here, 0.693 divided by 5.5 into 10 power minus 14 second inverse. So whatever the answer we'll get by doing it, that will be in second. Okay, so you can see your answer you should get, that is let me check once. The answer you should get out of it, that is basically 1.26 into 10 power 13. Okay, so let's go ahead. A first order reaction has a rate constant 1.15 into 10 power minus 3 second inverse. How long will 5 gram of this reactant take to reduce to 3 gram? Okay, let's go ahead. So we can start with the first order rate equation. 2.303 divided by K log is 0 by 80, right? So now K value is given, so let's put everything here. 2.303, K value is given as 1.15 into 10 power minus 3 second inverse, right? Now log, here it is starting with 5 gram ending with 3 gram, right? So now if I just go ahead, 2.33 divided by 1.15 into 10 power minus 3 second inverse. Now if you just split this thing, log 5 minus log 3, put the value here for the log, whatever the time you will get, that is your answer. Okay, so your answer is almost something like 444.4 second. Okay, this is the answer you will get out of it. Okay, so 2.303, yeah, let's go ahead. The time required to decompose SO2Cl2 to half of its initial amount is 60 minutes. If the decomposition is a first order reaction, calculate the rate constant. Okay, let's go ahead with the problem. So see, half-life is given, right? So from there K equals to 0.693 divided by T half, right? So 0.693 divided by 60, right? I'm keeping it in minute only, so it will be minute inverse, right? So yeah, if you just calculate this particular thing, then you will get your answer. So how much it should be? It should be something 0.011115, like this you should get. Okay, this is your answer. It's a very simple problem. I guess this is clear for you. Let's go ahead. The rate constant of a reaction, very important problem. Okay, this is a very important problem. The rate constant of a reaction at 500 Kelvin and 700 Kelvin are 0.2 second inverse and 0.7 second inverse respectively. Calculate the values of EA and A. Okay, let's go ahead. So for this case, we definitely have to use the Arrhenius equation. So log K2 by K1 equals to EA by R 1 by T1 minus 1 by T2. We have to find out EA at first. Okay, so I will just simply put the value and I will just tell you the answer. Okay, okay, so I'm taking here the log, right? So you have to multiply this side with 2.303. Fine. Okay, so now log 0.07 divided by, next one is 0.02. Both of them are second inverse, so it will be cancelled out. EA you have to find out. Okay, 2.303 into 8.314. Here if I just put the temperature, then 1 by 500 minus 1 by 700, right? So if I just further simplify this thing, it should be log 7 by 2, right? Log 7 by 2 means log 3.5. Okay, or better you can do log 7 minus log 2, that also you can do. Okay, so let's go ahead. Here EA divided by 2.303 into 8.314. Here I will get 350,000. Here I will get 700 minus 500, that is 200, right? Okay, so for this case EA will be equals to, put the value of log 7 and log 2, then you can go ahead with the calculation. Log 7 minus log 2 into 3500 into 2.303 into 8.314 divided by 2. Okay, so if you just calculate this part, if you calculate this unit, then you will get the EA value. Okay, so EA value overall you will get it something like, if you calculate this, the EA should come up to be something like 18.21 kilojoule per mole. Okay, 18.21 kilojoule per mole. Okay, I guess this is clear to you. Okay, let's go ahead. The rate of the chemical reaction doubles for an increase of 10 K in absolute temperature from 298 Kelvin. Calculate energy of activation. Okay, so again here we can use the same formula, that is log K2 by K1 equals to EA by 2.303 into R T2 minus T1 divided by T1 into T2. Make sure you are writing the formula properly. So here they are saying K2 is basically 2 into K1, right? So if I put K2 by K1, then K2 by K1, if I put 2 into K1 by K1, it will be cancelled out, so I will get log 2, right? So log 2 equals to EA by 2.303 into 8.314. Here temperature let's put. Okay, so initial temperature we started with 398 Kelvin, another temperature just raising 10 K. Okay, let's put, so raising 10 K with 298 means 308. 308 minus 298 divided by 298 into 308, right? So once you have to calculate EA, so log 2 value is 0.301, right, into the everything 2.303 into 8.314 into 298 into 308, right, divided by, from here you will get 10. Okay, and that is equals to your EA. Okay, so if you calculate this entire thing, you will end up with your activation energy. Okay, so EA value for this problem, if you check, it will come up to be something like 52.89 kilojoule per mole. Okay, I guess this is clear for you. Let's go ahead. A graph of log K versus log 1 by T for a reaction is linear with intercept 10 and slope of minus 5.1. Okay, the slope of minus 5.1 into 10 cube. Okay, calculate the frequency factor and EA for the reaction. Okay, so this is for like to deal with this problem, you must have proper idea about the Arrhenius equation, right? So let's go ahead with the problem. So see, if you just look at the Arrhenius equation, let me just write it for you once. So log K is basically equals to log A minus EA by 2.303 into R into 1 by T. Okay, so if you just see, this particular thing is your Y, this particular thing is your slope, that is M. Okay, this particular thing is your C, this is your X. Okay, so with respect to this, if I just go ahead, then from here intercept you are getting log A. So log A value is 10, right? So A value is coming up to be 10 power 10. That's it. Okay, another one you can see slope. Slope is given, so from the slope also we can calculate the energy of activation. So slope is given as minus 5.1 into 10 cube. Okay, that is equals to this minus EA by 2.303 into R means 8.314, right? So if you just calculate this, minus will be cancelling out. So EA equals to 5.1 into 10 cube into 2.303 into 8.314. So if you calculate this thing, you will end up with the answer that is 97.475 kilojoule per mole. Okay, that is your answer. I guess this is clear. This is also one of the very, very important problem. Okay, let's go ahead. Okay, next. For a first order reaction, show that the time required for 99% completion is twice the time required for the completion of 90% of the reaction, or show that the T 99% is equals to 2 into T of 90%. Okay, so let's go ahead. So we know if I am having a first order equation, let's calculate it for 90%. Let's calculate it at first for 90%. Okay, so T 90%, it should be equals to 2.303 divided by K into log. Initial concentration is 100 and after 90% completion it should be 10. That's it. So from here I will get 2.303 K log 10. Log 10 value means 1. So from here I am getting T 90%. From here I am getting T 90% is basically equals to 2.303 by K. Okay, so now what we will do, we will go ahead the same thing with the 99%. So 99% for this, if I calculate, T 99% will be equals to 2.303 divided by K log 100 by 1, right? So from this case, 2.303 divided by K equals to log 10 square, right? This 2 will come front, right? So T 99% equals to 2 into 2.303 by K, right? So this is only, it is coming, you can see. So from here I can write T 99% is nothing but 2 into T of 90%. That's it. Okay, I guess this is clear for you. Let's go ahead. Okay, a first order reaction has half-life 23 minutes. How much time will be needed for 30% completion of the reaction? Okay, let's go ahead. So for this case, it is also very, very important problem. So definitely we will start with the half-life calculation. So K equals to 0.693 divided by T half is how much? 23. Okay, so we will calculate it later. Okay, so now if I just go ahead with the first equation, I mean first order rate equation, T equals to 2.303 by K into log A0 by AT, right? So 100 was the initial, 30% completion means I have 70% left out, right? So from here, if I just put the value 2.303 by K value, if I put 0.693 into 23, here log 10 minus log 7, right? You can put the value here and you can just go ahead with the calculation. So your answer you should get as 11.84 minute, okay, something minute. Okay, that's it. I guess this is clear for you. Let's go ahead. Okay, a first order reaction has rate constant 2.3 into 10 power minus 5 second inverse at 500 Kelvin. At what temperature the rate constant of the reaction becomes 17.25 into 10 power minus 4. Okay, T2 you have to calculate, so Arrhenius equation you have to go ahead with. Okay, so let's see. Log K2 by K1, okay, equals to EA by 2.303 R T2 minus T1 divided by T1 into T2. Okay, so if I just put the values here, log K2 is how much? 17.25 into 10 power minus 4, okay, divided by 2.3 into 10 power minus 5, right, equals to, activation energy is also given but it is in the kilojoule, we will convert it into joule. So 191472, right, divided by 2.303 into 8.314, right. Now temperature T2 I don't know. Okay, better to write it in this way. Better to write it like this, 1 by T1 minus 1 by T2. T2 you have to calculate. 1 by T1 is how much? T1 is 500 Kelvin. 500 minus 1 by T2 you have to calculate from this thing. Okay, so if you just calculate this entire thing, it should come up to be something 75, I guess, if you do this thing. Yes, if you just go ahead with this thing, then it should come up to be log 75. Okay, so log 75, there are different way you can deal with it. See, log 75 if you are having, then you can go ahead with log 25 into 3, right. So log 25 means log 5 square plus log 3, right. So 2 into log 5 plus log 3. Like that you can go ahead with the calculation. Okay, so log 75 equals to 191472 2.303 into 8.314. Anyway, the log table will be supplied. You can directly, if you can directly put the value over there, that is also okay. Okay, or else the way I told you, log 2, 3, 5, 7. If you remember this much, you can calculate any value. Okay, so 1 by 500 minus 1 by T2. So I am not going for a detailed calculation now. So if you just from this thing, if you calculate further, your T2 value will come. Okay, so you can simplify this thing, log 75 value from there, log 5 value you can put, log 3 value you can put, and you will get it. Okay, or else you can directly put the value. Okay, and just simple calculation, you have to take it that side and you have to take the reciprocal. Okay, you will be given calculator, I guess you can do it. Okay, so you can see your answer will come up to be something like 551.5 Kelvin. I guess this is okay. Let's go ahead. This is also very important problem. Okay, the C14 content of an ancient piece of wood was found to have 3/10 of that of living tree. Calculate the age of that piece of wood. Okay, so let's go ahead with the decay constant. Here we will not tell rate constant, here it is decay constant. 0.693 divided by T half. Okay, let's put the value 0.693 divided by 5730. Here's inverse, right? So now we can apply it into the first order rate equation. So T equals to 2.303 lambda log here N0 by Nt. See here what they are telling is Nt is basically equals to 3 by 10th of N0. Okay, from there if I find out N0 by Nt, it is going to be 10 by 3, right? So that's what we can put here. So let's put the value of lambda here as well, 2.303 divided by 0.693 into 5730, right? So now log 10 by 3. So now the calculation is quite easy. If you put the value log 10 minus log 10 minus log 3, if you put 2.303 into 5730 divided by 0.693 into log 10 minus log 3, if you put the value, then you will get the answer. Okay, something in years. Okay, so you can see it should be 9957 years. Okay, I guess this is clear to you. Let's go ahead. Okay, the rate of a reaction quadruples when the temperature changes from 293. Okay, one more thing I wanted to tell, this particular problem is very, very important for this year. Okay, so make sure you are doing it. See, log 3 value is also given. Okay, so you can just put the value like that. So, okay, let's go ahead. The rate of a reaction quadruples when the temperature changes from 293 to 313 Kelvin, right? Calculate the energy of activation. So again we have to just go ahead with the Arrhenius equation. So let's do it. We already did this type of problem. So what they are saying basically, K2 is basically 4 times of K1. So K2 by K1, if I want to find out the ratio, so it should be 4 into K1 divided by K1, hence I am getting 4. So that's what I will put there. Okay, so log K2 by K1, make sure you are writing the formula. Okay, so EA by 2.303 into R, 1 by T1 minus 1 by T2, that's it. So let's go ahead, log 4, right? Log 4 you have to calculate EA, everything is given 2.303 into R value is 8.314. Here T1 is basically how much? 293 Kelvin. So 293 into 313, and here 313 minus 293. Okay, so if I just simplify the calculation, 2 into log 2 into 2.303 into 8.314 into 293 into 313 divided by, that's going to be 20, right? That is your activation energy. Okay, kilojoule per mole you can calculate. Okay, so activation energy, something you can calculate with kilojoule per mole, that's it. Okay, so you can see the answer is 52.85. I guess that's clear. Let's go ahead. The first order rate constant at 600 Kelvin is 2 into 10 power minus 5. Okay, one more thing, again this problem is also very, very important. Okay, let's go ahead. Okay, let's go ahead with the problem. The first order reaction constant 600 Kelvin is 2 into 10 power minus 5, and energy of activation is also given. Calculate the rate constant at 700 Kelvin. Okay, so this is a very, very important problem. Okay, let's go ahead. Here again we will start with the Arrhenius equation. Log K2 by K1, actually you have to find K2 here. Okay, at 700 Kelvin what is the rate constant, right? So EA divided by 2.303 into R to 1 by T1 minus 1 by T2. Let's put everything. Log K2 by K1, K1 value is given actually, that is 2 into 10 power minus 5, right, equals to energy of activation is given but in kilojoule. We will convert it into joule. So 209,800, right? Yes. 8.314 into 2.303. Here T1 into T2 is 600 into 700, and here 700 minus 600. That's it. Okay. So now K2 you have to calculate. So if you just calculate the entire thing, I'm not going ahead again, it's the same thing actually. Once you just calculate this side, you have to take the anti-log, means 10 power something, and then multiply this thing with 2 into 10 power minus 5. So K2 you can calculate out of here. You can get 8.14 into 10 power minus 3 second inverse. I guess it's clear. Let's go ahead. Okay. T half of a reaction is 10 minutes. For a first order reaction, what percentage of a reactant remain unreacted at the end of 50 minutes? Okay, let's go ahead with the problem. So for this case, what you have to do, you have to find out, there is a formula basically, remember this formula, okay? Fraction remaining is basically half power n. Okay, now what is n? N is basically total time that is required divided by T half. Okay, so remember this thing. Okay, from here I can calculate the n at first. Okay, so total time is basically 50 minutes divided by T half. Okay, so T half is also given 50 by 10 means 5. Minute will be cancelled out. Okay, so now fraction of remaining molecule, fraction remaining you can calculate like this. It's basically half power 5, right? From there what you will get, 2 power 5 means 1 by 32, right? 1 by 32. So percentage, if you find out percentage remaining if you want to find out, then 1 by 32 into 100. Okay, so something 3 point something you will get. Okay, so yes, 3.125. Okay, I guess this is clear. Remember this formula, you can go ahead easily. Next problem, calculate the time in seconds for the decomposition of nitrogen pentoxide which follows first order kinetics when concentration of N2O5 is dropped from 0.1 molar to 0.001 molar. Super easy problem. So here again we are going to use simple first order rate equation. I'm not writing the equation, but you should write all the time the only formula, but I'm just directly putting it here. 2.303 divided by K. K is 6.22 into 10 power minus 4, right? Log, initially I started with 0.1, I will end with 0.01. So if I little bit simplify this thing, 2.303 divided by 6.22 into 10 power minus 4 into, here I will get log 10 means 1. Okay, so T, if you calculate this much, it will be enough. Okay, definitely your answer will be in second. Okay, so if you just calculate this, your answer will come up to be something 3.7 into 10 cube. That's it. Okay, so I guess this thing is clear for you. Yes, this is the end of the numerical portion. As I told you that 15 numerical from the solution, 20 from the electrochemistry and 15 from the chemical kinetics. Yes, our agenda is fulfilled at the end of the lecture.